All right. So today we're going to learn how to build equivalent fractions. When I teach fractions, I'm very intentional on how I get students started. So today I'm going to just focus on building fractions from unit fractions. A unit fraction is when a denominator is, I'm sorry, a numerator is one. So you see that 1/2 is a unit fraction because my numerator is one. 1/3 is a unit fraction because the numerator is one. And 1/4 is a unit fraction because the numerator is one. So we're gonna learn how we could make these fractions into other equivalent fractions. And I like to use area model because it's very visual for students and it really supports a lot of our students that may struggle. So I'm gonna leave the 1/2 there. So if I was to draw a line through here, right? Let's pretend that I was able to cut it in a very straight manner and it looked equivalent. So you notice that the shaded area is the same, right? But now my number of parts have changed. So the area shaded is the same, but my number of parts have changed. So now this is 2/4, but 2/4 is equivalent to 1/2, right? So now I'm going to move on to the next one. This is still 1/2, same shaded area. Now I'm going to cut it the other way into 3 equal parts, right? And again, what's the same? Well, the shaded area is the same, right? But what has changed is the number of equal parts, right? So now we have 6 equal parts, and the number of parts that are shaded are 3. So 3/6 is another way to represent 1/2, which is another way to say 2/4. So now I'm going to break this one up into a half. And if I cut the half in half, I get 4. So this is a great idea for students to really understand that half of a half is called the fourth. So again, the shaded part is the same. That green section is still the same area. It just looks different now, right? I have the number of parts have changed. So now I have 8 equal parts and 4 of those are shaded. So 4/8 is the same as 1/2, which is this equivalent to 2/4, which is equivalent to 3/6, right? Let's try that same concept with 1/3, right? We have 1/3, 1/3, 1/3, 1/3. But if I was to draw a line strictly down the middle, my shaded area is still the same, but my number of parts have changed, right? Now I have 6 equal parts, and 2 of those are shaded. So I can say that 1/3 is equivalent to 2/6 because I could visually see it. And that's why I like to use area model to support students with equivalence. By the same token, I can draw 3 equal parts here. So again, what is the same? Well, the shaded area is the same. It hasn't changed. It's just what's changed is my number of equal parts went up to 9, right? And 3 of those 9 are shaded. So 3/9 is the same as 1/3, right? And we're gonna do one more. I'm going to cut the 1/3 in half. And remember, when we cut halves in halves, we get 4 equal parts, right? So let's pretend that I was able to cut it, same part. So again, question I wanna ask my students is, what's the same? Well, the shaded part is the same, right? That blue section is still the same. It's just now the number of parts still keeps changing. Right now, if I have 4, 4, and 4, I have 12 equal parts, and 4 of those are shaded. So I can say that 4/12 is the same as 1/3, which represents the same as 2/6, which is 3/9, right? Right here at the bottom, we have 1/4. I'm gonna give you about a minute to work out it on your own, all right? So try to see if you could follow the same concept I just followed. All right, so let's see what we were able to do. So if we cut the 1/4 in half, going horizontally, then the shaded region is still the same, right? But the number of parts went up to 8. And how many were shaded? 2/8. So 2/8 is equivalent to 1/4. And if I do that, same to the 3 equal parts going horizontally, then I know that that's 12 equal parts, same shaded area, but this time 3, right? Therefore, 3/12 is equivalent to 1/4. And if I do that here, 2, 3, then my shaded area is still the same, but now I have 16 equal parts, and 4 of those are shaded. One thing to keep in mind as you work with students is that if you're going to build force, notice that there's only 3 cuts inside of the area. So usually students get confused because they think, oh, force, they cut it into 4 pieces, but then that creates fifths. Or if you're working with thirds, they cut 3 times. But the real understanding is that if you want thirds, you gotta only cut your shape twice in 2 equal parts, right? So this is a great way to teach students how to build equivalent fractions, just starting with unit fractions. Later on, I'm gonna get into other fractions like 2/3 and 3/4 and 4/5 and all that. But initially, I want students to really, really understand this concept of unit fractions. So beginning with these 3 fractions, the 1/2, the 1/3, and the 1/4 is great. Thank you very much. I hope you enjoyed this video.